Laura, how are you?
I'm well, thank you, George. How are you?
I'm okay. I'm all right. I'm just, I'm at this conference here and I wanted to take a little break, and see what's going on and maybe answer some questions that people have out there. I guess these guys can wait for me, until we're
Of
done
course.
with this video. What do
They
you
look
got
like they're
there?
having.
Let's say, yeah.
I was just going to say they look like they're having their picture taken. They're waiting for you to turn around and take
I
their
got,
picture.
oh, there's Albert Einstein. Okay,
Hey,
this right here. Probably, I'm embarrassed to say, I don't know. All right, fellas, I'll be with you in a second, okay? Let me find my camera. Okay, just hold it, there. All
love
right,
it.
so, but you got a cool background. What is that?
Well, this is meant to be the chi-squared formula, although
Really?
only some of it is showing.
Oh, that's okay. Maybe we can figure out what the rest of it is, huh?
Indeed.
Chi-squared. Okay, so chi-squared, was there a test associated with that?
I believe there is. I've heard of the chi-squared test of independence. Are you aware of that one?
That's right. That's right. So if we have a certain, like, some kind of an event that happens specifically, and some other type of event might happen, is it where we try to figure out if the probability of one event happening changes according to what the outcome of that other event is, or if that other event has happened, something like that. If they're independent, does their probability change?
That sounds about right.
Something like that.
I wouldn't have said that it was a cause and effect sort of test, or perhaps more of a correlation test.
Yeah, I would say that too. You're just seeing, with the data that you have, is there a way to see, like, what's a good example? Maybe, you know what? I have a terrible habit. I'm a smoker. And usually there's probably I would imagine that the probability of me having emphysema would change depending if I'm a smoker or not. So maybe a chi-square test for independence on some kind of data like that.
That sounds like a good idea.
All right, cool. So let's actually, I don't have any data specifically, but let's kind of make some up. All right, let's say, let me see if I can get a whiteboard up here. Hopefully my handwriting is decent today. Can we see that?
I can see it.
All right, cool. So let's say that I've got, let me rearrange a few things here. Sorry, folks that are possibly looking at this video. Okay, so let's say I ask 100 people, let's say, so 100 people. And let's say I have, oops, this is not the best. These are not the best lines, but bear with me. Are they okay?
They're all right.
They're all right. They're all right. They'll do. All right. So let's say that I've got, I've asked, yeah, smoking and non-smoking, let's say, and people that have emphysema and they don't have emphysema. Okay. So I've asked 100 people, let's say total. Okay.
Sure.
And let's say about 30% of them, or 30 out of the 100 smoked, which means that the other 70 don't. Hopefully it's less than 30%, but let's say 30%. And out of the people, oops, let me actually do this because I kind of messed up already here.
Not to worry.
Seconds here. Yeah, I messed up. Let me do this. Let me get rid of that from there because I'm going to keep those as the total. So let me put in another column here and make this non-emphysema, let's say. So these are the totals we're looking at, okay? All right, not the best, but I'll work on it. I'll work on it.
That's fine.
So let's say, thank you. So let's say there's 10 that have emphysema. That means that 90 wouldn't have emphysema.
Sure.
Right. Okay. So, but let's say there's 5 of the 10 that are have emphysema. 5 are smokers, which means that 5 wouldn't be, right? And if there's 30 smokers, 5 of which have emphysema, seems that 25 wouldn't. right? Is that right?
I would say so.
And then what should go in this box here?
Well, 70 take 5.
Yeah.
65?
Sounds like 65 would be what we would end up getting. So this is again, a hypothetical situation. I'm not sure if it would be distributed like that, but let's say it was.
Sure.
Now, do we have enough evidence to show that these values that we have, the way that they're distributed among these 4 boxes, right? The 5, 25, the 5, and then the 65, if they're kind of far away from what they're expected to be. So when we say that they're expected to be something, okay, that sounds, if we're doing a hypothesis test, right? And maybe the null hypothesis in this case would be, what do you think?
I would say that the null hypothesis would be there is no link. There is no correlation.
I think so too. There's no change in the probability, like what we're expecting to get, that's what we're getting, right? So
Indeed.
I guess these are the actual values that we've got so far. Maybe we should compare them to the ones that we're expecting to get. If there was truly no, if they were independent, if the 2 events were independent. So in our null hypothesis, in this particular case, let's put that it's independent. Independent. And the only reason I'm writing this is because Laura's handwriting is horrible. Is it?
It is today.
It is today. I doubt it. I'm sure it's nice handwriting. I have horrible handwriting, definitely. So that
Looks
means
good to me.
does it? Thanks. Yeah. All right. So that means that our alternative, if we have enough evidence to reject the null hypothesis, that means that it would be dependent. So those are the 2 options that we have. So dependent in this case. All right, cool. So now when we talk about expected value, how are we going to figure that out? If there really is no, if the values that we're getting are close to what we're expecting. Well, how many people, what percentage of people are smokers?
30%.
30%. So if there's 10 people that have emphysema, I imagine if having emphysema and being a smoker were independent, then 30% of that 10 would be smokers, right? Does that make sense?
Yeah.
So I think that we're expecting this to be 3. Sorry, we're expecting it to be 3, but we end up getting a 5. It's not super far away, but is it far enough away? What value would I get here?
Are you saying 30% of 70?
Not 30% of 70.
30% of 65?
Not 30% of 65. Wait a minute, maybe I may have been wrong. You said, so how many total do we have how many total people do we have that have emphysema?
10 people.
So 30% of that 10 should end up being smokers if they're truly independent, right?
Sure.
So what does that leave for the non-smokers?
That would be 7.
That's right. So this should be 7 here. Still sorry, 7.
I just
Adding up to
embarrassed
the
myself
10.
there.
No, you didn't. No, you didn't. Not at all. Why would you say you embarrassed yourself? Don't say
Got it
that.
wrong.
Don't say that. Now, what's embarrassing is if we make the next video and you still didn't remember it, then it'd be embarrassing, okay? But I doubt that that's going to happen.
We'll edit this bit out.
Oh, this is the edit bit, eh? Oh, well, I'll tell you what. Well, we'll decide that later, but
Sure.
I don't think that there's absolutely no shame in it. Please don't say that. All right. So how about this number? Here's where you can redeem yourself. How about this number?
Oh gosh. If it's not 27, I'm going to be embarrassed.
All right. Look at that.
There we go.
Much better. See that? I told you. How about here? Don't be intimidated by these guys, okay? Just because they're wait. Don't be intimidated by them, okay? They're listening to us. What about here?
Well, that would be 63.
63 is right. exactly. So now we're basically got some expected values and we have what actual values the data is giving us. Okay, so now if we can figure out some way to be able to collectively see collectively if our values are far enough away from what we're expecting to actually say, well, we assume that they were independent, but we're getting these proportions that are kind of out of line here a little bit, right?
Mhm.
Okay. So I think what that's behind you, the rest of that graphic behind you, or that cool wallpaper that you found in your studio, it's very cool, is that we're going to sum up, we're going to find what's called the chi-squared statistic, and we're going to compare it to the chi-squared distribution, just like we would in any other hypothesis test. We got some kind of distribution, we have some kind of a test statistic, and we see where it falls in our distribution. If it falls in the tail, that means we reject the null hypothesis. So I believe this chi-squared stat that we're looking for is going to be the sum. I'm going to add up the observed minus the expected, take that bit, square it, and divide it by the expected value. And we're going to run through each one of these, in this particular case, each one of these 4 categories that we have. So taking this one here, this one here, this one here, and this one, oops, that's an asterisk. So 4 things that we're going to be adding up. Okay. And that's going to give us our chi-squared distribution, so our chi-squared value. Then we'll look at the chi-squared distribution and see, are they truly dependent? Do we have enough information? Does our test statistic tell us specifically? Does our data tell us specifically that we can reject the null hypothesis of independence to show that they're dependent? All right. So what is it going to look like over here? I guess it's 5 minus, you tell me.
5 minus 3.
Over
3.
Yes, and do what with this?
We need to square that.
Where it add, oops, that's supposed to be an add. Go ahead.
Oh. So next one, let's do 25 minus 27.
All right, that sounds good to me. Why not 27 minus 25?
Well, it probably wouldn't make a difference in this case because it's being squared, but in order to pay attention to the formula that we've been given.
All right. Okay.
Let's do that.
Okay. See, you redeemed yourself from that. What? That's 7. All right. So this is over 27 and add.
And then let's do 5 minus 7.
5 minus 7. We're going to square that over the
over 7.
7. So we're kind of weighting each one of these, right? How far away are they from their? What's that distance squared, right? Expected minus the observed. That deviation squared over the expected value. So if you're off by 2, it's not weighted as much if you're expecting to get 63, right?
Sure.
Or in this particular case, well, this one, the 7's weighted a little bit more, but then this last one, you can see that it's going to be over what?
It's going to be over 63.
63. Yeah. So that one's going to really get, weighted not very much. So that's what, 65 minus 63. I don't know if I've done everything correctly. I think I put all the observed minus the expected.
Looks right to me.
All right. So now it's the toughest part of all of this is trying to figure out what this value is. Do we have a calculator?
Not on me.
Oh,
There's
Lordy,
probably one on this
Lordy.
on this laptop.
All right. Are you going to do this for us?
Sure.
All right. This is where, while Laura's figuring out the value for us, you get to talk about what's for it's going to be for dinner today. I wonder.
I'm very sorry. Wait, was that aimed at me?
No, I'm just if it's, I tell you what, if it's gonna distract you too much from calculating, don't worry about it. Okay, maybe it's just a question that's going out to the audience. What kind of dinner they're gonna make?
Well, shall I give you some numbers?
Yes, of course. That was fast, right?
So the first one is going to be 1.3 recurring.
1.33 going on to infinity. Cool.
Okay,
Next
so
one.
the next one is 0.148
Boom, that's repeating. There's a multiple of 3 under there, the 27, so that makes sense for some repeating. Plus or equal, sorry, or plus. Let's spin it.
This one is going to be 0.571429.
That's good enough. And then the last guy is kind of small points.
Oh, I don't think this guy's going to be very big at all.
Yeah, I don't think so. It's not going to add much, but let's see what we get.
0.06349.
0.06349. Okay, cool. So if we add those all up, we get what about 1.8, 1.9 maybe?
Let's have a look.
Let's see, these two together about 0.7, maybe almost close to 2, just under 2, right?
I have here 2.11626.
2.11626. All right, let's check it out. So we've got a value now that we're able to compare to a chi-square distribution to see if we're going to end up in the tail portion of this particular this distribution. Wow, okay, that's bigger than I thought.
Me too.
That might be enough. Just going from the 5 to the 3 may be enough to show that they're dependent. All right, so I think what we need to do here is I'm going to kind of show people something, if that's okay with you.
Absolutely.
I've got a little bit of R code that I created that kind of shows the chi-square distribution. So I'm kind of proud of it. So I'm going to show it. That's okay.
Absolutely. I'd love to see it.
All right. So how's that?
Wow.
Really?
Yeah.
Really?
So,
Cool. So
what are we looking at here?
What I've done here is actually use a little bit of code here. Let's see if I can find it. A little bit of code to create a chi-square distribution. So I ran some X values, some Y values here. I denoted some degrees of freedom here because a chi-square distribution, the one that is basically a family of distributions. So according to the degrees of freedom, which kind of are dictated by how many, in this particular case, how many categories we have, meaning I don't know if I'm using the word correctly, but I've got smoking, non-smoking, and emphysema, non-emphysema. So however many different options I have along those two variables, those are going to dictate what my degrees of freedom are going to be. To be able to choose the chi-square distribution, the appropriate chi-square distribution. So if we're familiar with the t-distribution, which is a family of curves, they kind of look like the normal, but they kind of change their shape a little bit as the degrees of freedom go up higher and higher and higher. Same thing kind of happens with the chi-square distribution. So the first one, I don't know if you can see it very good, but see it very well, sorry. But it's basically this first one that's right here. So for the degree of freedom 1 for a chi-square distribution, that's the only one that doesn't originate at the origin. All the rest of them, you can see 2, 3, 4, 2, 3, 5, 10, and so on. What happens is that this, can you see my cursor?
I can, yes.
Okay, so this bit right here, ideally is coming from the origin. This one as well, this one as well. All of these are coming from the origin. And as my degrees of freedom get bigger and bigger and bigger, that peak gets a little bit lower and moves a little bit more to the positive side. So these are all chi-square distributions. The distinction is what degrees of freedom are we looking at? Okay. In our particular case, it's degrees of freedom 1. And this is the way that we figure it out. Okay. And I'm going to stop this share here and go back to the whiteboard.
Okay.
And what's going to happen is however many I have here, that's 2, right?
Mhm.
There's 2 categories, there's 2 different options there, there's 2 different options here, okay? I'm gonna think of this as 2 minus 1 and 2 minus 1.
Okay.
So my degrees of freedom are always gonna be equal to the product of however many categories I have here minus 1, and however many categories I have here minus 1. So in our case, it's 2 minus 1 times 2 minus 1. That's 1 times 1. 1 is the degrees of freedom.
Makes
There-
sense.
If there were 3 across here, then I'd be looking at 3 minus 1. I'd have 2 times 1. I'd have 2 degrees of freedom, and so on.
Sure.
Okay, all right, so now let's figure out, let's see if we can find specifically what value that is. Okay, so how are we going to figure it out? We have to look at a chi-square distribution, I guess, or we can even use RStudio to help us figure out what that is specifically. So I'm just going to use RStudio if that's all right with you.
Absolutely.
Okay, so let's see here. Let me kind of set it up. I can go down towards the bottom, and you have to forgive me if I don't remember specifically the command, but that's what makes these videos fun, I guess.
Absolutely.
Or boring or whatever. So let's see. I think I've got something up here that talks about the chi-squared. Our random chi-squared. I think this is it. Random
Excellent.
chi-squared. So I'm going to copy this there and copy this. And I imagine when I paste it here, oops, there's a bit of paste, please. All right, there it is. And I give it however many values, I guess degrees of freedom. No, this actually creates a distribution using a chi-squared, a random chi-squared distribution. This is not what I want. I'm sorry. This is not what I want. Well, let's see if there's something else here. I'm gonna start typing CHI chi-squared test, not test. Chi-squared distribution is what I want. Let's see. .dist. No.
Would it be CHISQ for chi-squared?
CHISQ.
I'm only guessing myself.
I think this one right here that's coming up is a chi-square test. It's when you actually have data to be able to perform this chi-square test.
Okay.
But I think it's a shame that it's you've taken this turn on this video. But let's see if I can save ourselves here. Save myself, I should say.
We're in it together, George.
We're in this together. I should have spent more time, like, getting this ready than the photo of these guys behind me.
Not to worry.
I know. So let's say RStudio. Sorry, folks, chi-square distribution. Yeah, there we go. Let's see if we can get this going here. See, where did we? You know what? I think you said it originally, didn't you? You were really close. Here's what they're telling us to use here. All right, where you guys, everybody, you can still see the how do you call it, right? You see that bit at the bottom there? 0.95 degrees of freedom, blah, blah, blah.
Yes.
I think that this is going to help us. All right. For those who waited, now the big reward. So let's put in degrees of freedom 1. Okay. And go ahead, question.
No,
Oh,
just a comment.
So what I think here is what we're going to find here now is that we're going to, I'm pretty sure we're looking at the 95%, right? You go from 0 up to 95%.
Mhm.
And then chop it there, and it gives you what that chi-squared value is. So if our chi-squared value pops up here, and it is less than 2.11, we would have proven that smoking and emphysema are dependent.
Nice.
It's exciting, isn't it?
I'm excited.
All right, let's check it out.
I do have a question, however.
Oh, go ahead.
So the 0.95, is that related to the significance?
It is, it definitely is. In fact, because we usually set our level of significance to what?
5%.
That's right. So I want a tail that's 5%. So what
Sure.
we've done here is asked our student to start at 0 and go across the distribution until 95% of the distribution is behind it, giving
Nice.
us that level of significance up at the top. Perfect. Beautiful. Absolutely
Ooh.
wonderful. That's exactly right. But notice a little bit kind of anticlimactic. What did I get here?
Well, 3.84 is bigger than 2.11.
Yeah, so I think if we go back to let's go back to this whiteboard here. I think what we've just found is that, let's see. I think we found that in our chi-square distribution, which in our particular case looked like this because there's 1 degree of freedom.
Mhm.
We drew a line of the critical chi-squared value, chi-squared, the critical one, where we had a level of significance of 5%, right? We found to be, what was it, 3 point something or other?
3.81, was it?
3.81, we'll call it. I think you're right. I'm checking. 3.84. Okay. And we got our actual test statistic that ended up somewhere. Let me use another color. Our test statistic ended up somewhere over here. So that's where we got the 2.11, I believe, the chi-squared value.
Mm.
So our p-value is this, which is more than our level of significance, meaning that the null hypothesis of independence,
Mhm.
well, we fail to reject.
Oh dear.
So we don't have enough evidence to show that one depends on the other, that there's a dependence there. Maybe if it was 6 instead of 5,
Maybe that would have been enough.
that might have been the kicker. I imagine that might have been the kicker. Anyway, how's that?
Very nice.
Is that
Thank you
okay?
for showing me that.
No problem. And thanks to everybody for waiting. We're going to take their picture now, okay? Are
Excellent.
you guys ready? All right. All right. All right, Laura, that was fun and looking forward to the next one.
Great. See you next time.
I'll talk to you soon.
All right. Bye.
Bye-bye.